are you? This is Trev and welcome to my blog. Welcome to part 3 in my TIG welding series on how I TIG weld, butt weld, thin car bodywork steel together. And that's pretty much what I use the TIG welder for. I occasionally weld the odd bit of aluminium as well. I'd just like to say huge thanks to all those people that have emailed me, especially the ones that have offered me lots of advice as well. I've probably received in excess of a dozen emails with people offering me amazing advice on how they use the TIG welder. What I do find quite interesting though is if you put all this advice together, there's a lot of things that don't meet up. A lot of people disagree with each other on how they do different things, but what I have noticed is they achieve the most astonishing results, and I'm really blown away by a lot of the stuff that people have sent me. Pretty humbled by it in fact, and I'd just like to say thank you very much for sending me these. What I do take from this is that what you should do is you should watch as many of these kinds of videos as you can. If you pick up something that's really good from me and you think, oh, this is fantastic, I'm getting on with this really well, thanks Trev, then pick that up and run with it. If you try something out that I do or show you and it doesn't work for you, then just dump it. Just watch as many of these videos as you possibly can, because I just really think, weighing it all up, that there's no one path for any person. All these machines all behave differently from each other as well. If you don't all use the same machine, obviously there's personal preference. I think how you're taught something as well originally, if you pick it up and it works, then you just keep doing the same thing. You're less likely or inclined to try out other methods of and other ways of doing things. So anyway, I'm going to stop rambling on. I hope you enjoyed part 3. From a user's perspective, I have without doubt found that a lighter torch is much more beneficial than the quite heavy 200 amp torch that most units will come with. They're quite big and clumpy, it's quite heavy. Also the lead isn't that flexible, has a tendency sometimes to sort of try and twist out of your hand slightly, and in general it's a little bit of a brute to use, particularly when you're only welding 0.9mm steel. You're going to be getting into some pretty awkward positions when you're welding up cars, up underneath wheel arches and things like that, and the last thing you want to be doing is wrestling something that you're trying to weld with. So we've got a lighter torch at work, so I asked Artec if they could supply me with something lighter, and they've supplied me with this 125 amp CK worldwide torch. Immediately, as soon as I pick it up, it is just so light. It is incredibly light, and there is no resistance in the cable whatsoever. It just goes exactly where you want it to. We haven't got the same torch as this at work, so I haven't plugged this in yet and tried it out, and I'm itching to do that. I'll just talk you through some upgrades on the consumables side before I do this. So let's talk briefly about tungstens. Confused? You will be. I don't know a great deal about these, but what I do know is that when I swap and change them around into the torch, it definitely does seem to affect the weld, mostly to do with cratering and sparks flying off and things like that. So what I've been welding with in the demonstration is a thoriated tungsten, which is a red tipped one, and yeah, it seemed to weld pretty good. There was a bit more spitting than I'm used to. Now this is the one that we use at work, so this is a serrated one, and this is a grey tipped one. This is an all-rounder for aluminium and steel. Like I say, this is the one we use at work, and yeah, very happy with the results on that. However, I have been deluged, as I said, with emails of people, and pretty much everybody agrees on one thing, that the lanthanated tungsten is the best for TIG welders that are inverter type TIG welders, not transformer ones. So I've bought myself some. Now I typically weld with a 1.6 on steel. If I do aluminium, then I hop up to 2.4. What I've bought is I've bought some more 1.6s. Actually I must get some more 2.4s, lanthanated ones, but I thought I'd just give these a go first. So I got me 1.6 that I'm familiar with for size, I've also bought some 1mm lanthanated ones because a lot of people say that you should really match the tungsten to the thickness of the material you're welding, which is something I don't do. I just pretty much use 1.6, like I say, for my thin steel, and then 2.4 for aluminium, because I find that the 2.4 resists the heat a little bit more because there's a bit more mass there to absorb that heat. So this is it. This is about as much as I know about the subject. I've never used these, so I'm going to give them a go. This is what would be regarded as quite a fairly standard setup, I would have said. So I've got my new torch here, and I've got a cap in the back. Now I've got a very long cap in the back, and the reason I've got this is because it's got a brand new tungsten, and this cap will take the full length of the tungsten all the way up without the tungsten being too long, too much sticking out of the ceramic cup. Now this is great and it works absolutely fine. The problem is when you get into a confined area, the torch can then become too tall and the cap can get you know, stuck on things and become a bit of a nuisance. You can also sometimes feel the weight of the cap on the torch, which can be a little bit disconcerting sometimes, but it's not too much of an issue normally. So what I normally do is, when the tungstens get a bit shorter, so you've sharpened them up, you know, 20 or 30 times, and they're about a third of the length as they were when they were new, you can then of course put a shorter cap on. So I keep some real short ones. If I'm in a confined space, then I can put a dead short tungsten in. Then I can get away with a much shorter cap, even shorter. And that means that I can get the torch right into a confined space, you know, with just that in the back. As you can imagine, you're going to get that into a lot of tight spaces. So that's that anyway. So we've got the cap in the back and the cap's loose. So have that loose. And then we've got the collet on the tungsten. So take the tungsten off. So you got the collet. That just simply fits into there. And the collet is pretty self-explanatory. When you wind the nozzle down on the collet, so you wind that down, you wind this into the torch like that. So that's in, that's tight, and then you get your tungsten and you feed your tungsten in like that, and that should just slip straight through the collet because it's not tight. Then you got your ceramic cup. Like I say, this is all the standard stuff. This is the stuff I always use. Try not to get that crossed on there like I just did. So you tighten that up against there, that seals in there. There's a little O-ring as well in the back of the cap which stops the gas from escaping out the back. Now this tungsten, you see, is loose. So what you do is you then tighten the cap up to lock the tungsten into place. That can't move now, and that is the basic setup. Quite straightforward really. So I'll talk about the other setups. You could use the gas lens kit. So something else that you might want to consider is a gas lens kit. I've got some standard sizes here, 1mm, 1.6, 2.4, 3.2, and these replace the collet body or nozzle. Literally just screw straight in like that. You just do it up exactly the same, and it's got like a little mesh gauze in there, and what this does is it acts like a diffuser. If you imagine a strip lamp and you're looking at the strip lamp and that harsh sort of beam of light coming out, then you put a diffuser on there that scatters the light out, makes it softer. Well, this kind of acts the same. It diffuses the argon gas and it provides a nice envelope of gas around the weld area. If you imagine it's coming out of those little jets on the standard nozzle or collet body, you can sort of appreciate what I'm saying, I think. And yeah, that just simply, you can get a stubby ceramic kit like that, It just screws straight down on the side. The other benefits as well is you can have your tungsten hanging out a little further than you normally would, because you've extended your reach of the gas envelope. The other thing you could consider, apart from having a standard gas lens kit, is you can replace the ceramic with a Pyrex cup. So you just literally slip this rubber O-ring over the top, and then you can put the Pyrex cup over the top like that, and that just ensures that it doesn't come off. It makes a seal. A lot of people talk about you being able to look through the cup at the weld. I suppose because you've got a wider opening there, I can see the advantages of that. On a narrower cup, I don't personally ever see a problem with being able to see the weld pool myself. I suppose the wider the cup, the more chance there is going to be of you obscuring your view of the weld, and also a wider cup is going to give you even greater gas coverage. Of course, you're going to have to turn up your gas flow a lot as well. I've not used this yet, never used one, so I'll be interested to see. The general consensus is that people buy these. This is from the limited conversations I've had. They buy them, quite like them, but always revert back to the standard ceramic cups, which they prefer these for longevity purposes more than anything else. Without a doubt, one of the greatest benefits of having a torch like this with a flexi head, because you need to get the torch at a nice angle, fairly upright as it will go, and so your wrist will only bend so far, also dependent upon the position you find yourself in as well. So what you can do is, if you wanted the torch more upright, you'd have to twist your wrist around like that to get it up more. So you could bring your wrist back down this way and simply bend the head over to get yourself, I mean, if you were welding something that had changed direction, it was sloping down away from you, and you just wanted to weld over the top of something like this, then of course you could just simply bend the head over like that, and that is extremely advantageous. I can't stress how important this really is. It's a fantastic thing to have, to be able to just move that rather than have to extend your reach. Up until now, I've just shown you how I fused two pieces of material together. Because it's guillotine cut, there's absolutely no gap there whatsoever. So when you butt them up against each other and start welding, of course the heat generated from the weld also pushes the metal together because of the thermal expansion. This means that we get a nice seamless weld with virtually no undercut whatsoever. Now, back in the real world, something that's hand cut, filed, we're going to have all sorts of little odd gaps going on here and there, so you really need to use some filler wire. So I've got my new welder set up here, and I've got some filler rod. Filler rod, you say? Yes, I use MIG wire as filler rod. I don't use filler rod as filler rod. So I've got some 0.8 and I've got some 0.6. I always use 0.8 MIG wire to use as filler rod when I'm TIG welding. I've got 0.6 because I wanted to use 0.6 on this machine because I haven't used 0.6 for so long. I stopped using it years ago. I said in a previous video that I got fed up with it just spooling up inside the machine I had, so I changed up to 0.8, and at the time I didn't really notice too much difference, to be quite honest with you. I was still welding quite thin stuff with the 0.8 and I've used it ever since, never really had a problem. But this machine's been given me by Artec, and they said that they'd supply some MIG wire, so that they've provided some 0.6. I've also gone ahead and bought another reel off them of 0.8 because I wanted to see what the difference was. Cracking little machine this, just looking over it now, just so gutted I haven't had the chance to really put it to task yet. I'm going to do an upcoming video. I'm going to put this through the motions, and I'm going to hopefully show you why it's best to have both MIG welder and TIG welder for car body work. I'd like to show you the advantages of having both systems, really. So yeah, it's a cracking little welder. All metal parts, metal rollers, so you just simply switch that around to select either 0.6 or 0.8, whatever you want. Yeah, it's a real nice looking bit of quality kit, this is. Nice all metal construction on that. Can't wait to get it going. It's so dinky as well compared to my old one. The main reason I didn't introduce filler rod into the previous videos was because I wanted to keep it as simple as possible. So I think if you were to start down the road of TIG welding, I think get yourself a sheet, get it guillotine cut up into these sort of size, get lots of practice in, get to understanding and get the feeling of what's going on when you're fusing two pieces of metal together, because it's all pretty much the same really. Once you start introducing filler rod, all you're doing then is just giving yourself a residual amount of material there to compensate for any gaps or anything that you've got. What I do is I meter out some wire, normally turn the wire speed right up so we're not waiting all day, and let out about, I don't know, what's that, 300 or 400 millimeters possibly, to be specific. So something that's a nice kind of manageable length. You don't want a sort of full length filler rod, because what you do is you just cut a filler rod in half anyway because it's too long to use. So you want to dispense what you're comfortable using, that kind of length, maybe just a little bit longer. So the thing with using MIG wire for filler rod is it comes out and it's got a natural curve to it because it's been mounted onto a spool forever. The thing that can be quite frustrating when you're using MIG wire, especially when you're using gloves, because you really should use gloves because of the UV issues associated with welding, is the wire is very hard to hold, because when you tighten your grip on the wire, it does this. It spins around in your hand like that, like a flapping seagull. So what we need to do is try and straighten this out. The thing is, if you try and straighten out a piece of MIG wire by just bending it back on itself, you get absolutely nowhere fast. So there's a simple little trick to straightening out a piece of MIG wire. I'll show you how to do it. Take your MIG wire and take off about 1.5 inches or so, and then just fold it over like so. And then you will end up with something that looks something like that. The other end, the loose end, put in a vise. So put that in the vise, that's trapped in the vise. Then get a drill, something like this, hold on to the chuck and trap the wire in the chuck. Then holding tension on the wire, just literally wind it up. The wire now has gone through a process of torsion. It's twisted, and it now has got like this tension going on it that has made it completely straight, usable and perfectly manageable. A little bit like my hair. I typically weld at this kind of angle, pushing the weld bead along. And why do we use MIG wire instead of standard filler rod? Well, a standard filler rod, much thicker, welding at very low amperage. As soon as you've established a weld pool and you get the welding rod near that pool, you're going to hit it and instantly you're going to transfer all the heat out of the pool into the rod and just kill it dead. With the MIG wire, it's so thin that you hardly notice any difference at all when you're welding. So when I weld, like I say, I kind of weld just off the upright position, pushing along. And if I was gas welding, I would go in at sort of 245-degree angles like this. The problem is, if you do that when you're TIG welding, of course, you're going to end up touching the tungsten with the rod. So what I do, I mean, it's easier to show you this than actually do like a proper live demonstration when I'm welding, because it's so hard to film it and to be able to see what's going on, because obviously the arc kills the camera. So I'll be pushing it along like this. And what I do, again, this is all personal, guys, we're all different, but what I do is I try and keep the rod, I lie it, you know, quite sort of flat, offer it up to the arc flame. So I may do about 2 or 3 millimeters of welding once I've established a little bit of residual of excess then in the pool of filler rod. Then I'll just kind of put it in the path of the welding flame, and as I move the tungsten towards, so the torch is going along, you'll find that where the arc flame, as soon as it starts getting close to the filler rod, the MIG wire, a little bit will melt and bead off and zap straight into the weld pool. And what this does is it just tops the weld pool up. Like I say, it's giving you this residual that you want. Now, you don't want loads of this stuff. It's quite hard to put it into terms, but you get the feel for it after a while, how much you actually need, because you don't want there to be loads on there. You don't want a big bead that you then got to spend a lot of time filing down or grinding off afterwards, but you want enough there so that it gets rid of the undercut situation. You want it so that when you grind it off afterwards, you've got a lovely flush weld, everything's completely invisible. The other thing I will say as well, makes no difference going in from that direction or coming in from this direction. This is what I do a lot of times, because again, like I say, you haven't always got access. Lots and lots of great YouTube videos all showing stuff just trapped in the bench with somebody stood directly upright. Easy peasy, you got lots of access. You know, you can see what you're doing very easily, but it's very different when you're welding on cars. So again, you may have to come in almost like a right angle. Again, just lie the wire quite flat to the panel, come in. As soon as it gets near that arc flame, a little bit will just melt off and it will just literally bead straight into the weld pool, almost like it's drawn into it. And that's it. I do sort of 3 millimeters of weld, offer up the MIG wire again, and it'll just zap straight into the pool. Keep moving the torch steadily, offer it up again, it will bead off again straight into it, and it'll just keep topping that pool up with that extra bit. If you've got a gap, of course, then you're going to be into the situation where you're going to have to put more filler into your gap. Obviously this is guillotine cut, so it hardly needs any, but you know, that's basically it really. That's what I do. So let's do some welding. Okay, as before, we're all jigged up, ready, cleaned up. I've got my torch set up with the gas lens, and I'm using a 1mm tungsten, which I normally wouldn't use. I've got the gas lens in, ceramic cup. The weld is set to the 22 amps. No upslope, no downslope. I'm just going to get it tacked in first, and then I'll put a bit of upslope and downslope, and we'll get this welded together. something I've noticed immediately is seem to have better ignition than before. So I'm putting a bit of upslope and a bit of downslope on it now. It does look cleaner, and we've definitely got better ignition. So let's put some filler rod into it now. Okay, so that's come out pretty good. Not very pretty, I can appreciate, but you can see there's definitely a bit of a bead there now, whereas before things were completely flush. So I'm just going to give this a tap up with a hammer, and then I can give it a grind off and we can see what we're left with. I can't see any craters. I forgot to say about not using the pulse and things like that. A lot of people keep going on about using pulse welding and stuff. Tend not to use this myself because it seems to put a structure to the weld, and when you're doing bodywork, the last thing you want is like a structure to the weld. People talk about stacks of dimes and things like that. Not really after that. I'm after it to look as smooth as possible. This doesn't look that smooth, I can appreciate that, but when it's ground up it's going to look quite good, I think. It's all finished up now. I just went over with a little grinding disc on the Rolock tool just to take the bead off. I've then polished this up with a 80 grit DA disc and then a 180 just to finish up. Obviously don't get carried away with this, otherwise you just file it thin. Got a nice material thickness along the edge as well. I don't know if you can see that on the camera. Yeah, it's come out quite well. With regards to the gas lens kit, I felt like the weld was certainly cleaner. Regards to the lanthanated tungstens, I certainly found that the ignition was a lot cleaner. I didn't notice a great deal of difference using the 1mm over the 1.6. The only thing I did find was, because of my failing eyesight, I found it a little bit harder to sharpen up the 1mm to actually see what was going on the tip. But yeah, it certainly welded really nicely anyway. Well, thanks very much for watching. In part 4, I think what I'll do is I'll go over a couple more things, might get onto a couple more of the torch settings, so go into the 4T mode, also possibly crack open the foot pedal as well, and maybe even start doing some more practical applications, like showing you how you can cut a repair section out and make it fit a new section, and then butt weld it together using the methods that I've just shown you in this video. Anyway, let's pick a winner. Part 2, I offered up these 2 mugs. Let's see who won these 2 mugs. The answer to the question was, what was my interview with Artec called, and it was called Meet the Welder. So let's go and pick a winner from that. Rog, you are the winner, my friend. All you have to do to claim your prize is send me your address. My email is in the link in the video description. Just let me know what your address is and I'll post these mugs off to you. Okay, so that's it for this time round. Thanks very much for watching. Catch you in the next video. I'd just like to say quickly, anybody wants to see any updates on the van, I have started a new channel called The Baking Bird. It's all about the van and baking and my wife and that side of the business. I will be doing regular little updates on the van, little goals that we've accomplished. I'll stick a link in the video description if you'd like to follow us on there. I know a few of you are really bursting to see part 20. Had a few panicked messages and emails after the after one of the videos I put on about the van update, where people are just thinking that was the final part. No, it isn't the final part. There will be a part 20 in all its glory, and I'll talk through the things I did you know, since you saw part 19, so you'll see the thing, you know, completely finished from part 19 right the way through to the van being on the road and us up and running and out trading. So anyway, that's it for me. Bye for now.